just what keeps on happening.
Okay.
So how would you, let's say, do the first one here?
Is that just 2x?
Yeah. Next one.
4x cubed.
Yeah. Any idea about next one?
Is that x to the minus 1, or does it just go away?
So at the moment it's x to the 1.
Right.
So after you differentiate it,
X to the 0, which is just 1.
yeah, and so that's just going to be 1. And that's because the gradient of the line y equals x is 1.
Right.
Let's say question E.
Minus 3x to the power of minus 4.
Yeah. How about G?
8x.
H.
There's 7x to the 1, so from 7x to the 0. Is it just 7?
Yeah. And that's because the gradient of the line y equals 7x is always 7. How about J?
I have no idea, sorry. Just get rid of it.
Yeah, it's basically 0. And that's because the gradient of the line y equals 3 is 0. It's a flat line across. Yeah. And the rest of those are fine. So this is a different way of writing it, dy dx. First one.
5x to the power 4 plus 2x.
Yeah. How about C?
4x cubed. Just 4x cubed.
Yeah. 4x cubed. And you're okay for the rest of those. Is it? Okay, this one, fractions and a different letter. What would be part C?
Half t to the power would have been minus 1.5.
So you half minus 1.
I'm not sure.
So you just do half minus 1. And 1 is the same as 2 over 2. So minus a half.
Right.
Let's say D.
2/3 t minus 2/3.
What's 2/3 minus 3/3?
Minus 3/3. Minus 1/3.
Yeah. 1 is the same as 3/3. E.
3 minus 2. 6/8 t.
So do you have a calculator?
Yeah.
So just do 3/4 times 2.
3/2.
Yeah. 6/8 is exactly the same as 3/4, so it'll be unchanged. Yeah, and that's the power of 1, so that's fine. How about G? You can always use your calculator.
Is that 7/2?
Yeah.
Uh, 70. And then 70. And then to the power of 5/2.
That's it. So absolutely nothing wrong with using your calculator for these. And they make them a bit more complicated, but the same idea. Let me just check. This next one uses a different notation. I'll just do one. How would you do part G?
Part G. Minus 3x. Minus 3, sorry.
What's minus 1 minus 1?
Minus to the power minus 2. I was thinking add 1 for some reason. And then minus 3/2. And then 15/2 x. Minus 3/2 minus 1. And then minus 5/2.
That's it. So that's just a different notation. F of x becomes f dash of x for dy dx.
Yeah.
Okay, this one, 5a. How do we do this?
I don't know how to go about that one.
So you have to rewrite these into what's called polynomial form,
Right.
like index form.
So could you do y squared equals x?
Well, x to power x, the square root of x, that's the same as x to the power of what?
Same as x to power a half.
Yep. And then you do it.
So half x minus half.
Yes, half. Yep. How about C?
Uh, 6x plus x, 1/3 plus 1/3 x to the power of minus 2/3.
Yeah. How about G? How's that written in polynomial form or index form? So that would be x to the 5 and that whole thing to the power of a half. So that's x to the 5 and the whole thing to the power of a half.
Right.
How do you simplify that?
Can you just add the 5 and the half?
What's the index rule for?
Times, sorry.
Yeah.
So 5 times 2.5.
Yeah, I'm going to write as 5/2.
Yeah.
Just because it's so, no work out. Okay, and so dy dx?
would be 5 over 2x.
Mm-hmm.
I'm going to have to use calculator because
Yeah.
2 minus. It's 3 over 2.
Yeah. That's it. Okay. Let's now go back. How about B?
5 4 minus 1 over x. I'm not sure how you'd write that. The 4 just goes away, gets rid of itself.
Yeah.
Goes to 0.
And this can be written as y equals 4 minus x to the minus 1.
Minus. So it's just minus x times minus 1. It's just x to the minus 2.
Yeah. So D.
X. Is that written as x to the minus 3? Start with.
No. So 3 is already on top. X brought up.
So is it just written as 3x?
To the minus 1.
The minus 1.
Yeah.
Right.
And then, so the dy dx bit is pretty easy. So let's try A. So convert that into index form.
Fucking 1 over 4x written as I don't know.
So I could rewrite this for a bit of clarity. A quarter times 1 over x. So what is 1 over x the same as?
X to the minus 1.
Yeah, so you could write that as a quarter x to the minus 1. And then how about the next second half?
X squared to the minus 1. I don't know. This is 1 over x squared, isn't it? Not just 1 over x.
Yeah, so x squared to the minus 1. Can you simplify that?
2 times. Yeah, minus 2.
Yeah, x to the minus 2. So it's 1 over x to the plus 2. It becomes x to the minus 2. And then differentiating it isn't tricky. So I'm just going to keep going with putting these into polynomial form. Let's see. Okay, any idea about f? Just do it one step at a time.
No.
So what is 4th root of x? How do you write that as an index?
X to the 1 over 4.
Yeah, so that's x to the 1 over 4. And then what would that be after the x is brought up?
X to the minus 12.
Yeah. And then you would differentiate that. And let's try h.
Is it 3x squared to the minus 1? And then simplified.
What question are you looking
H.
at?
Part A, I was looking at part B. 8 root x. X to the 1 over 8.
8x to what, sorry?
I thought it was x to the 1 over 8.
No. So 8 times root x is the same as 8 times x. What's power?
Half.
Yeah. Okay. Any idea about second half?
No, so I was just trying to work out.
Another way of writing that would be 4/3 times 1 over x squared.
Right.
And so you're always changing the x bit.
Is x to the minus 2.
Yeah. Well done. And then you just differentiate it as normal. So writing it in polynomial form, fractions, that's, I think, where you're having difficulty with these. So these, I think, are going to be okay. We'll check. How would you do part A?
T squared plus 3t.
And then
2t plus just 3.
yeah, so these, you just expand the bracket first. That's the way you put them into index form.
Yeah.
Okay, so this one, 7. This is what we need to work on. Okay, how would you do A?
X. Is it? So it's x to a half times x.
Well done. And that's the same as x to the 1.
So is it just x to the half?
So what's the rule for?
Add the powers if you times it.
Mm-hmm.
So 1.5.
Yeah, I'll write it as 3 over 2.
Right. And then x. And minus 4x to the half.
That's it. I'm not going to differentiate it. You're good for differentiation. I just want to see something. Okay, these are all quite similar. Any idea about B?
No.
So if you have x on the bottom, what's that the same as?
It's the same as to the minus 1.
And so that would be exactly the same thing, written a different way.
Okay.
And then you would expand that. We'll expand that in a second. What would be part C?
The x to the minus 2.
Mm-hmm.
And then bracket 4x cubed plus x.
We'll leave that D.
X to the minus half.
Well done. Okay, so now this next one you're going to get wrong. E.
Is that x over 2?
It is. Don't forget, if x is on the bottom, what does it become when it's on the top?
Minus 1.
Yes. So it would be x over 2 to the minus 1, or x to the minus 1 over 2, and I'll write it as a half x to minus 1. So basically, so divided by 2 is same as times by a half. Because of BIDMAS, the index is connected only to the x. So you could do 2x all to the minus 1, or 2 to the minus 1 x to the minus 1. But it's easier. We only care about the x. So that's to the minus 1, and then that's still just a half. Okay, how about F?
X to the minus 2.
Go on.
And then bracket 5 plus x to the half.
Hold on. X to the half. G.
1/3 x to the minus 1.
Brilliant.
9x minus 2.
And last one.
Is it 1/4 x to the minus a half?
Brilliant. And then that's all the same. Okay. So expand B. What do you get?
X to the minus 1 times x squared. And then minus 2x times. Is that just minus 2x?
So this is to the 1. So what power is left over?
The minus 1. The 1, sorry.
So you do minus 1 plus 1.
Yes, it's 0.
And so
so just minus 2.
Yeah. So minus 2x to the 0, or minus 2. Next one.
4x. X minus 2. Plus x to the minus 1.
D.
X to the power of half. Plus 3x to the minus half.
E.
Is that 1.5? 3.
Just a half.
Alright. Half x minus 1. 2x to the minus 1. And then minus a half x squared.
F.
5x to the minus 2 x, plus x to the 1.5, 3 over 2.
And g.
1/3x. 3x to the minus 1.
So that's to the minus 1. This is 2. This is just x.
Oh, it's 9x, sorry, yeah. To the 1, so 0. It's just 3.
Yep.
And then minus 2. 5. 3 minus 2. I'm too sure about the second bit. Does it just cancel out? It's just 3.
It's just that times 2. Put in your calculator, 1/3 times 2.
Oh, 2/3. 2/3 x to the minus 1.
That's it. So, and then you would then differentiate each of them, and you can see just how easy it would be to differentiate those. So, yeah, the difficulty we're having was putting them into polynomial form, and that's not uncommon. So, any questions about any of those?
No, it's just remembering them, I think.
Yeah, I mean, okay. So this one here, have you seen this before?
Yeah, you just differentiate twice.
Just differentiate it twice. What would be step 1 for part A? Let's actually, we'll do 1. Okay, part A.
Part B or E, sorry.
E.
E.
Yeah.
So is it x to the minus 2?
Mm-hmm.
And then brackets 3x 6 minus 4.
Mm-hmm.
And then we'll expand them to get 3x to the 4 minus 4x to the minus 2.
Mm-hmm.
Differentiate once would be 12x cubed.
Mm-hmm.
4 times to the 8x to the minus 3. And then differentiate again to get 36x squared plus minus, sorry, minus 24 x to the minus 4.
That's it. Any questions there?
No, that seemed alright.
Yep. And so that was that type. How do you do this one, part A? Hang on. That's a bit weird. Let's do part B.
Okay. Integrated. Do you need to differentiate first?
Yeah.
So you get 4 minus 2x.
Mm-hmm.
X coordinate, and then can you put 3 in?
Yeah.
So 6, so you get minus 2.
Yeah. So the derivative is called the gradient function. It's a formula for finding the gradient of a curve at a point. This is kind of a little trick. 2a. Yeah, how would you do 2a?
You have to differentiate again.
Mm-hmm.
Start with, so you get 6x.
Yeah.
X minus 5. Sorry. Plus which is it's 1x. So it's just plus 1.
Mm-hmm.
And then the 5's gone.
Mm-hmm.
6x. Find the gradient. Oh, is it 1 minus 1? So 6, 1, 7.
Yes. So the thing they're testing here is if you will sub in 1 instead of minus 1.
Yeah.
Because that's the x. You don't need the y coordinate, which in question 1 we didn't have the y coordinate.
Yeah.
This is a different way of writing. What does this mean? F dash of 4?
Which one, sorry?
3 part A.
Oh, yeah, right.
What does that, just even before part A, just what does this mean? F dash of 4?
That's dy dx still.
Yeah, and after what's the 4 about?
The 4, is that what you'd need to sub in?
Correct, that's all it means. You've got these coordinates, let's see, curve. Find the gradient at those different points. It's kind of an interesting one. Let me think. Okay, it's kind of an important one. This one. Okay. Any idea about this?
You just move it down a little bit, sorry, please.
Oh, sorry.
Cheers. Oh, that's fine. Cheers. A curve with equation. Y equals x cubed. I'm going to differentiate first.
Okay.
To get 3x squared.
Yeah, okay, go on. 3x squared.
Minus 8x plus 3.
So part A just said find the coordinates of A, B, and C.
I'm not sure how to go about it.
So what do you know about when it crosses the x-axis?
The gradient 0.
No. Something 0.
The x coordinate 0.
No, x coordinate could be 3, 4, minus 1.
The y coordinate.
Yes, and so the y is 0. So y equals 0, and so what could you do there?
Drawing a blank still.
Literally y is 0, so instead of y equals, it's 0 equals.
Yeah.
And then you have to solve that. What calculator do you have?
The FX85GT.
Okay, so you can't do this with your calculator. You just any idea how to solve that?
No, it's cubic and not quadratic. So.
They all have x in common.
So you can take a factor of x out of them. So x squared minus 4 plus 3.
Did we forget squared somewhere? That should be squared, sorry. 4x plus 3. Yeah, and then?
No. Still there.
So x equals 0, or tell you what, this thing here, what would that be in double brackets?
X. And then x to the start of the other one as well. X squared. So the two numbers that need to times together to make 3 or the minus 4?
Take 3.
Right.
Add to make minus 4.
Don't know.
Minus 3 and minus 1.
Right, alright.
When you have a plus c and a minus b, they have to both be minus. So solutions, x equals
3 or x equals 1.
And there's one more.
Or x equals 0.
Yeah. And they said find the gradient at those points for part B. So how would you do that?
Then put each of those into the equation.
Yeah. So you'd do that for all 3 and you'd get all 3 answers. So what was I going to say? Yeah, it'd be much easier if you had the 991EX calculator, because then you can just put that into your calculator and it gives you x equals 3, x equals 1, x equals 0, or just old-fashioned factorizing and all that. If it crosses the x-axis, that means it's when y is 0.
Okay.
Any questions about that one?
No, I don't think so.
Okay. Let's try this one. 5.
Four x minus 5 divided x.
Yeah, Andy.
Divided x equals 7. 7 equals, so 7 equals 4x minus 5.
Mm-hmm.
So 12 equals 4x.
Mm-hmm.
12 over 4 equals x, which is just 3.
That's it. So that's quite a common one. When is the gradient a certain thing?
Yeah, that seems quite straightforward. That one.
So I think the only thing that's was thrown you was its cubic. Of course, points at which the gradient of the curve is 4. That's okay. Gradient, let's say point. Okay, these are important. So they're mostly quadratic, but when they're cubic, I think that throws it. I'll see if we can get one more of those ones before we finish. Okay. An idea about this one and that's connected there.
Y equals 2x. So y would be, and the equation of the tangent So y would be. So I'm putting x in. You get 4.
Mm-hmm.
Y would be 4. Gradient is 4. So is the gradient minus a quarter?
So when you put 2 into the gradient function, you get 4, like you said. So that is the gradient.
So we've got to find the equation of the tangent.
Mm-hmm. You might not know it.
No, has it got something to do with the negative reciprocal?
So you're thinking of equation of the normal. Equation of the tangent just uses the 4, the same gradient.
Do you have to bring the 4 into the equation?
Yeah. Into what equation?
To the original.
No. So in general, so a tangent, what type of what does that look like?
It's just a straight line touching the
Yeah.
curve at a given point.
What's the equation of a straight line in general?
Y equals mx plus c.
So that's one way of writing it. And do you know another way of writing it?
I know there's a longer way involving x1 and x2.
That's it. Y minus y1 equals m x minus x1. So you know how the gradient is y2 minus y1 over x2 minus x1?
Yeah.
So if you multiply both sides by the denominator, this is what you get. Y minus y1 equals m x minus x1.
Oh.
And so we only have one x and y, so we don't have x2, y2, we just leave those blank. Sub in the y value for y1, the m for the gradient for m, and the x coordinate for x1. What do you get?
So y minus 4
Yeah.
equals 4 brackets x minus 2.
And that's your answer. It's an equation. It has y, it has x. That's it. B.
Y equals x squared. So differentiate again to find the gradient. 2x plus 3. So the gradient is 2. The gradient is 1.
Yeah. And I'm just going to get that method marked for that. Okay. And so you can now write your final answer.
Yep. So y minus 2 equals 1. X minus minus 1 plus 1.
Yeah, so minus minus becomes plus. And I just want to do this last one, so it's a cubic. D.
D. 3x squared minus 8x. So 3 is 27 minus 24, which is 3.
Okay.
So the gradient is 3.
Yep.
Gradient is Can I just put it into the y minus y1 or is it something?
Yep.
Y minus y plus 7, sorry. equals 3 bracket x minus 3.
Well done. So I think you're good for that one.
It didn't really change the fact that it was a cubic, did it?
No, it didn't really affect it that much. Find the equation of this one. So these next ones, I'm not going to do them, but basically the next ones want you to actually expand the bracket and simplify at the end. These ones didn't ask you to do that, so we won't bother. And then this one is the equation of a normal. So this is the one you were talking about. How do we do this? So how about part A?
Uh, 2x.
Mm-hmm.
That's it. So the gradient is 1.
X coordinate is
2. 2.
2. That would be the gradient of the tangent. We want the gradient, sorry, we want the equation of the normal.
Is minus x over 2.
Yeah. Or in this case, minus a half. Minus 1 over 2.
Right.
And so, final answer.
Y minus y plus 3 equals minus a half x plus minus 1.
Minus 1. For this one, they want you to put this into, so there's no fractions. How do you go with that?
Expand the bracket.
Yep.
So minus a half x. Minus 1. Is that just plus a half?
Yeah. What would you do next?
Float 3 over to be minus y equals minus half x plus a half minus 3.
Okay. What is a half minus 3?
Minus, I'll do it on calculator.
Yeah.
Minus 5 over 2.
Okay. And what would you do after that?
Half x. Minus 5 over 2.
So they wanted it equal to 0. And they wanted there to be integers, so no fractions.
Put the y value
in. What would make it not fractions?
Index form.
Timed everything by the denominator.
Oh yeah. Yeah. So y, 2y.
Yeah.
Minus x. Minus 5.
And they want it equal to 0.
So minus x minus 2y minus 5 equals 0.
Yeah, that's fine. Or make your life easier and turn it into x plus 2y plus 5 equals 0.
Yeah.
Both are correct. So the most important bit, you did that very quickly and easily. And then this little bit at the end, we want it in a certain form. That's tricky because it's in fractions and all stuff. Any questions about
that? No, that would seem alright.
Let's see. This one, they wanted it in the form y equals mx plus c. Let me think. Yeah, that's a good one. I have to do it. Okay, how about this?
Differentiate first again. 6x minus 5.
Yeah.
And then put the x coordinate to get a gradient. So 12 minus 7 is the gradient.
Yeah.
So that, do you, instead of using the y minus y1, do you use y equals mx plus c?
You might as well use y minus y1 and then just rearrange that.
Okay. So y minus. We don't know the other y.
Yeah.
Don't take care. Can you just leave it as y minus y1?
The question gives us a formula for finding the y coordinate.
Oh, right, yeah. Y equals mx. So 7 times 2.
Well, you don't know what c is. I mean this one. This is y equals.
Put the x coordinate into the original equation.
Yeah.
So 3, 2 squared minus 5 times 2 plus 2. 2 squared is 4, 12. 4.
You add 2 at the end. So it becomes 8, doesn't it? Or maybe I'm wrong. Oh, you're right. 4.
Right.
Okay. And then?
And then we can do it in the y. So y minus 4
Yeah.
equals 7x minus 2.
And then turn that into this form. How do we do
it? Expand out the bracket.
Mm-hmm.
So I've got 7x minus 14. Y minus 4, and then float the 4 across.
Mm-hmm.
To get minus 10. So y equals 7x minus 10.
X minus 10. And how about part B?
They're normal to the curve.
No. Hang on. How would you get the an equation for the normal to the first curve? If there was an A part 2, what would be the normal to this curve?
Minus 1 over 7.
Yeah.
The gradient. So, and then is it just y minus 4?
Yeah.
Minus 1 over 7. X minus 2.
And you would just expand it and all that, which we already did.
Yeah.
So that's most of differentiations. Differentiation is huge because you've got it. It used to be in C1 and C2. Increasing and decreasing functions. Gradient is negative, it's decreasing. Gradient is positive, it's increasing. So they've, written a different way. Stationary point, do you know what that is?
No.
That's when the gradient is 0.
Right.
So you find y dx, make it equal to 0 and solve it. So we were solving it when it was equal to 7 and -7 and all sorts of stuff. Stationary points. Sketching functions, it's just x and y coordinates. That's not that one. And then this tricky one at the end is modeling with differentiation is definitely the hardest one. And that's the only one we didn't get to. So gradient of a curve is the gradient of the tangent at that point. This whole thing comes from y2 minus y1 over x2 minus x1. If you do that for a curve instead of a straight line, you get this formula where it's power times coefficient and subtract 1 from the power.
Yeah.
And you can prove that by doing y2 minus y1 over x2 minus x1 for a curve. So different ways of writing it. F of x is f dash of x. Y becomes dy dx. There's different. You can use different letters. Y minus y1 equals mx minus x1. The normal is the negative reciprocal. The function is increasing, decreasing. Yep. So d squared y by dx squared is the same as f double dash of x. They both mean double derivative. Stationary point gradient is 0. So you do dy dx make equal 0. And then f double dash of x. So local minimum, local maximum. We didn't get to that, but that's when the double derivative is bigger than 0 and double derivative is less than 0. So if you get a plus number, it's the minimum. If you get a minus number, it's a maximum. So we didn't see that. That's part of the modeling thing. So how do you feel about differentiation now, Conall?
I definitely feel a lot stronger on it.
So especially just takes practice with all the minuses and the fractions and stuff. So if you want, we can do that last bit of differentiation next time, or we can just leave it and do integration or something else. Do you have any preference?
I think I feel more comfortable if we went over the last little bit.
Okay.
And then moved on into integration.
Okay, we'll do that. Any questions for me in general?
No, that's it. Thank you.
Okay. Well done, Conall. You did great. I look forward to talking again next week.
Cheers, Darren. See you next week.
Have a good week. Goodbye.
You too. Bye.